Okay, thank you everyone for joining me this evening. If you are living in Lagos, Nigeria, from everyone else joining from other parts of the world, I say good morning, good afternoon, good evening, wherever you are living on the globe. So we are just going to jump right into the agenda for the day and then talk about what it is that we are here for. These are the Web3 dev sessions, and this is our third webinar in this series. We're going to be talking about understanding blockchain data with particular focus on token information regarding the ERC20 and ERC721 standard. And then during the course of this session, we'll take a look at the Ethereum improvement proposals that were written on the ERC20 and the ERC721. We'll explore token address data and then explore token holder information. And then we'll talk about Covalent Hackathons, that knowledge of the information that we share in this session would give you that ability to be able to take part in Covalent Hackathons and go ahead to win amazing prizes. And then just to whet your beak here, we are currently running the hackathon where we're offering $10,000 in prizes. My name is Emmanuel Oahina. I'm currently working DevRel at Covalent, and you can connect with me on Twitter at Imaodia. I see it as a mission to focus on what it is I can directly impart and directly influence to bring about a change. And for me, that is getting a lot more African developers aware of what is going on in the Web3 space, right? And helping them transition from Web2 to Web3. For this session, we are talking about the ERC20 and the ERC721 tokens. And why do we have to have this conversation? So it is estimated that by 2025, we would have millions of critical information on public blockchains, right? And then dozens of uses and multi-usage, right? And thousands of applications, and then billions of users on chain. And a lot of the activities that will be carried out on chain would basically be around token information, right? Either using the ERC20 token standard where you are able to transfer, token asset from one user to another, right? And even in DAOs where you have token gating, where only token holders might be able to like vote on proposals that are raised in the DAOs, right? And a plethora of use cases for token, as much as my favorite aspect of tokens, which is NFTs, but particularly as they relate to data. So we just jump right into the ERC20 and the ERC721 EIPs. But that said, we have to first of all, talk about very basic terminologies regarding tokens, right? And would stick with the two most important concepts: fungible and non-fungible. This session assumes that the people watching this and the people here in the webinar understand token terms. You have probably interacted with tokens. You are actually token holders, right? Or maybe you're not, but you have heard these terms, or maybe you have not. But if you've not heard these terms, I am just going to tell you to please be patient. If you have heard these terms, I just want to use this as an opportunity to, use this to remind you what it is fungible and non-fungible represents. And if you do, interact with hold tokens, I suppose you know this, but it doesn't hurt, to have a reminder. Fungible in its very traditional sense, right? It means that it has a value that can be equated, to have value in one form as against another, right? So what that means is that a user with a unit of $100, right, can be able to equate that unit to another user who has that same unit of $100. What that means is that such a user can be able to transfer his $100 to another user, right? Either as a way of saying, making purchases, or as a way of exchanging value, basically. What fungibility means is that it can be transferred it holds value, and then it can be equated to another unit. Non-fungibility means is that it actually has a unique ID, it actually has a value, but it cannot be transferred. A popular example that a lot of people are aware of are NFT arts, right? But we'll still go to talk about a lot more about the ERC721, especially the aspects that are like, for the record, EIP means Ethereum Improvement Proposals. And these are proposals that are submitted by developers in the Ethereum space on particular standards that should be adopted generally by the Ethereum community, right? And that is, the baseline of decentralization, right? It is decentralization in opinions, it is decentralization in contributions. So basic definition, the EIP20 token standard is an interface that allows any tokens on Ethereum to be reused by other applications from wallets to decentralized exchanges. Practically what that means is that it has value, and when you transfer it from one point to another, that means the value is not lost and it can be used as a form of exchange. We will just take a look at the proposal pages, right? So typically the proposals are available at eips.ethereum.org, right? And then I have already clicked on to the ERC, standards, right? And then we have a lot of them on here. But the ones that we are going to be talking about today are the 20 and then the 721. So typically, when you get to the website, you'll be able to see information about the authors of the particular token standard, right? And this was submitted by Fabian, and I am sure a lot of us know about Vitalik, right? He was one of the guys that, brought about the whole Ethereum blockchain thing. And then you have a context that, shows you the abstracts, the motivation, and practically also the methods and events, available, using this particular standard. But I really do not, I would recommend reading this, right? As when you want to get, a general overview. But if you want to get like deeper into understanding what a particular proposal offers, it is best to go to the GitHub where all proposals live, right? And it is available github.com/ethereum/EIPs. And then you'll be able to go into the particular directory containing all the EIPs and see a list of all the EIPs. All the EIPs are here, and there are so many proposals, so many proposals. But like I said, we are focusing on the 20 and the 721. So this is the particular proposal for the 721, right? And for those of us here who are front-end developers, I am just going to dive right into the methods available. So the methods basically demonstrates what the token is about, right? And particularly, they are like your JavaScript functions, and particularly what is expected in terms of token behavior for any token to say that it has met the standard of being an ERC20 token, right? The name is optional, right? Symbol is optional, decimals are optional, but it must have a total supply, right? It must able to return the balance of, for those who have read Solidity or are learning Solidity, you would understand a couple of these things. But for those who do not, typically what is signify are, like I mentioned, methods that every token that meets the ERC20 standard must have, right? It must be transferable, right? And then it must have a feature where you are able to transfer from an address. Let's just take a look at the transfer from. So looking at the function, you see that it typically tells you you can transfer from, and then it takes in 3 parameters, right? It has the from, it has the to, and it has the value. Solidity is a statically typed language. What that means is that for every variable declaration, you have to specify that the particular type of that variable. So you see that it has the address type, and then an unassigned integer type of 256. So what that means is that when you are calling the transfer from method, the address that it is being sent from must be an Ethereum address. The address is being sent to must be an Ethereum address, and then it must hold a value. That means I am sending from this address, and I am sending maybe 1,000 units of this token, 1 million units of this token, or even 1 million billion units of this token. And then when you call this particular function, it must return a Boolean, which is either true, or a Boolean success, which is either true or false. A true in this case means that that transfer was successful, and a false in this case means that that transfer was not successful, which could be due to numerous factors. Either the address that is sending it does not have, enough tokens to send to the person receiving it, and a couple of other, factors. And it is said to be public because public functions in a contract means that it can be called by anyone making use of that contract, right? You cannot write a method to transfer from a particular address to another without setting, and then not set it to be able to being used by everybody. So that is what public means. And then you have the approve, which allows, the spender. This is very useful when you are, withdrawing from a wallet, from a faucet, yeah. And events. So events typically are emitted whenever you call any of these methods up here. It is just a way of communicating, information that when this particular token was transferred, a particular event occurred, and it goes into the log of a particular transaction, right? So I would try as much as I can not to go into high level stuff and make this overwhelming, and just focus on what it is that we are here to discuss. So this is the proposal for the ERC20 token standard. And like I said, if you want a very deep in-depth matter on the subject, it is best to go read it on GitHub as against reading it on the proposal's website. And then my favorite, we have the ERC721 token standard. So why this is my favorite is that in conversations about NFTs, the conversations is principally about digital art, right? Digital art that is sold on OpenSea, and people just flipping this art and then making humongous sums of money, right? But this is not what I enjoy most about NFTs. What I enjoy most about NFTs is that it's you can even grasp it from the definition. It says a standard interface for non-fungible tokens. And like I said, non-fungibility means is that it has a unique identity and it cannot be transferred, right? Not it cannot be transferred, but rather it cannot be, it cannot be exchanged, right? Semantics there, just use of English, but I hope I explained that well enough. So it is also known as this, the rationale. The NFT word choice, right? It says NFT was satisfactory to nearly everyone surveyed and is widely applicable to a broad universe of distinguishable digital assets. Honestly, did is very descriptive for certain applications of this standard, especially as regards to physical property. For those that might be familiar with law terms, right? A deed is principally a contract that can be used to signify ownership for a lot of things, for land, for house, for assets, right? For insurance, for cars and everything, right? But a lot of the attention and focus right now is principally more on digital arts and digital collectibles. But I really hope that in the not so distant future, we'll be able to see a lot more focus on other aspects of NFTs, with a specific focus on the definition of the use of the word dates. So that said, this session is really not to go have a deeper technical dive into the the technology of the token standards, right? And maybe possibly build out stuff from there. But really, it's to give you like this overview, and then we'll go into what information we can get, right, from these particular tokens. And then we'll be learning about that by exploring the token address, data, and token holder information. And to be able to understand this, I am going to talk a little bit about Covalent. So I'm going to introduce the Covalent API. So why the Covalent API is important is that data operability is essential at scale here, and blockchains produce limitless amounts of the data, limitless, every single day, every single minute, right? If you go on Interscan right now, you would see that the block heights are receiving, newer transactions coming in. And we define it as a no-code API, and it enables access to multi-chain data, which we are going to see a demonstration of right after this slide, right? So the way that Covalent operates is that we have the blockchain layer, right? And then we set up nodes, and then Covalent sits as a data layer. What we do is we retrieve information across multiple blockchains via our nodes, and we make it available to users via JSON and via CSV. And you see that what you can do is that you can build a plethora of applications, from identity, from chats to dashboards, from consumer to consumer apps, right? And then so NFT, and then be able to explore wallet information and just make it available to users. The advantage for a Web2 developer getting into Web3 when using Covalent is that you really do not have to get into that place where you have to learn Solidity, where you have to, learn ERC20 and then make, so much of a deep dive into it. Yeah? Possibly you're working at an organization where you have to return day-to-day information about the number of users using your token, or you just want to build a multi-purpose dashboard where people can be able to see the token and the value of the token that they hold across different chains, right? And I'm just going to quickly go into a demonstration. Like the topic is about, right? It is about understanding blockchain data as regards token information, right? And understanding blockchain data as regards token information, with this particular focus on the ERC20 and the ERC721 standard. So this is the Covalent docs, right? Prior to using the docs, you have to first of all go to the covalenthq.com website and sign up for an API key by going under developer and getting a free API key. And then when you get to the docs, you would be able to use different classes of endpoints. We describe them generally as a class A and a class B endpoint. So I am not going to go deeper into that aspect. I'm just going to quickly go into a quick demo and show you how you can use this information to quickly start building out dashboards, participating in hackathons, and winning prizes, right? So this particular first endpoint here, it is the get token balance for an address. And like I said, we support multiple blockchains. So as at last count, our list of supported networks across mainnets and testnets are 19 in all, right? We have support for Ethereum, for Polygon, for Avalanche, for Binance, for Phantom, for RSK, and a plethora of others, and for testnets as well. So what that means is that if you take a cursory look here, you will see that each of these networks has a unique chain ID. And to explore the information across each of these chain IDs, we can begin with the get token balances for an address. For each of these chain IDs that you saw earlier, you can take any of them, pass it in here, pass it any address. It could be a contract address or a regular wallet address. For Ethereum, it could be an ENS name, right? And then for RSK, it could be an RONS. So what you can do is that when you pass this in and set your API key up here, I have already made a query knowing fully well our local internet. I don't want to have any issues. But that said, I am just going to quickly, clear the data already return and make another request. To be very particular, this address that I passed in here, I got it from Etherscan, and that is the address of the Covalent token. Yes, we actually have issued a token, but this session is not a conversation about tokens, please. So I pass in the address, pass in the chain ID, click on try, and I am able to get back information regarding the token, right? And it shows you the quote rate is actually the value of the token in USD, and it shows you the quote rates within the last 24 hours. So if I were to pass in a wallet address, you would get a whole lot more information from that particular address. And I did mention that you can pass in an RONS. So I'm just going to use demo.it to do that and click on try. And let's just wait for a few more seconds. Hopefully my internet is not too slow in returning this information. Okay, so while that is coming through, what I would want us to look at regarding the ERC20, okay, yeah, so that is the response for the demo.it address. You can see that demo.it holds BNB, it holds SFA, it holds Uni, it holds Rare, and a plethora of other tokens, right? So imagine building a wallet lookup app, right? So as against writing very complicated queries just to return data, possibly using ROPC endpoints from any node, you can simply use Covalent, right? You just build it, a very simple dashboard. All of this data is in JSON, pass in your API key, hide your API key with .env, right? And then just make it available, make it possible for a user to pass in a wallet address through an input feed, and then it gets returned their balances, as long as it's based on the ERC20 token standard, right? And you can do that for multiple, blockchains. As against people going to sign in into Binance to see their current balance, you can build a simple dashboard where any user can pass in their wallet address on Binance. As regards NFTs, if you want to get NFT information, very simple. Still using the same endpoints, all you just have to do is set this particular input field where you just set NFT Boolean. Yeah, Boolean, you set it to true, right? And then you make the request. So the responses here is available in JSON, and also it's available in call. You can actually take this particular URL, pass it to your browser, and see all the responses that is returned. What other thing that I want to demonstrate is getting token holder information as of block height. I suppose everyone here understands what a block height is, but in very basic terms, blockchains are arranged in blocks, right? And every block carries a number of transactions within a certain period of time. and these blocks are connected. That means that is how information is validated block height by block height. So for every particular block height, you can see all the transactions that are taking place on that particular block height. And just to quickly rush through this demonstration, I'm going to show you something critical here, which you can do for any other token, for any other contract. So this is the Covalent query token, CQT, right? And it says the current number of token holders is 5,462. And this, you can use the token holders information to get, the number of token holders as a block height. So what you do is pass in the chain ID, which is Ethereum in this case, pass in the address of the particular token, which is CQT in this case. So to get block height, we have an endpoint called get all chain statuses. So when you call the get all chain statuses, right? It gives you the chain information. This is the chain ID. What we are really interested in here is the particular block height. Yeah. So when you copy this particular block height, come back to the get token holders as a block height, pass in the block height. Click on try and make the request. So why this return data here is different is that, like I said earlier, the Covalent data is available via JSON and via CSV. To get data return in CSV, you set the format string input to CSV, click on try, and then it returns this data. So you can take the call URL, pass it into a web browser, hit it, and then it gives you a downloadable CSV. That downloadable CSV, you can open a Google Sheet, right? Import it, and you will be able to see every single address that holds that particular token, and then every single address that holds that particular token, right? And the balance on each of those addresses. You would understand how important this is if you were to do your own research regarding any particular token, just to ascertain its utility. And this information is very, very critical if you are working in DeFi, because you'll be able to use this to build graphs that you can use to understand where a token has been. I am not saying that you can use that information to understand where a token is going to, right? But you can understand where a token has been and do your own research, using that information. And a plethora of use cases, right? And like I said, with a focus on the ERC20 token standard, right? And the ERC721 standard. And you can also use this to, understand how many token holders are holding a particular NFT or a particular digital asset. And using this information, for data scientists, you can take this information, extract it into a tool like Power BI or Metaverse, and be able to build, very amazing dashboards from there. So still a focus on the ERC20 standards and the ERC721. So this is basically how Covalent works. Like I said, we extract blockchain data, put it in nodes, and then we offer Class A endpoints, Class B endpoints. Class B endpoints are very, very unique because they show you particular data from very, particular platforms such as decentralized exchanges, and you'll be able to see, liquidity data, swap data, and every other data that you suppose you would find relevant and make use of. That's the entire session. And then just to recap on what we went over here, we started by looking at the ERC20 and the ERC721, looking at the Ethereum improvement proposals and particularly what those standards are about. And we looked at the transfer form function method for the ERC20, right? And then we saw that we could emit events for that. And when we took that information and brought it into the Covalent API, you could see that you could use that information to return data. And why is that data relevant? Is that transactions are always happening on chain, and it will be amazing to build more tools that users do not have to like bug themselves about monitoring their assets across different networks. Historical portfolio of a particular token over time, right? What that means is that if you pass in any address, like I did, I passed in the Covalent address here, you can get the particular token information either in a 7-day period or in a 30-day period, and you'll be able to see the high and low and close balance of the day that that particular token opened at. What that means is that you can practically build a dashboard to track an asset. And that said, I'm just going to close off with saying that you can join the Covalent Discord, and we have hackathons currently ongoing. With that, we have come to the end of this session.